Okay, here we go. Symbolize and solve inequalities. Lionel has, at most, 63/8 cups of flour to bake cookies and a cake. Lionel uses 7/4 cups of flour to make the cake. If each batch of cookies takes 3/2 cups of flour, how many batches of cookies, X, can Lionel bake? Select the inequality that includes the maximum number of batches of cookies that Lionel can bake. So right away, we're talking about a limit to what he can do. He can't cook an infinite number of batches. There's a limit, there's a maximum. So if we're looking at our answers, which ones of these symbols indicate a maximum? And the answer is C or D. Less than or equal to is another way of saying at most. So X, the number of batches of cookies that Lionel can bake, is either at most 49/8 or at most 49/12. It can be both those numbers or less, but it can't be more than that. A and B don't make sense. We could say the number of batches of cookies is greater than or equal to 49/8. He can greater than or equal to. There's lots of numbers that are greater than. Could he cook a billion batches of cookies? No, that doesn't make any sense. So before we even write an inequality or solve an inequality, you can use some common sense to see that your answer here has to be C or D. So let's go ahead and write and solve an inequality for this problem. 68 cups of flour max. That's how much he has. He uses up 7/4 right away. So 7/4 is gone. And every batch of cookies takes 3/2 cups. So we can write the following inequality. We have 3/2 cups times the number of batches, because every batch takes 3/2 cups. So we start with 3/2 times X. This is the amount of flour that one batch takes times the number of batches of cookies. So this is the total amount of flour for all the batches of cookies. Plus the 7/4 cups of flour that he used to bake the cake has to be less than or equal to the total amount of flour he has available, which is 63/8. And so now we're ready to go. Now we have fractions in this problem. There's a couple different ways to do problems like this. You could just do the problem normally as if they were regular old numbers. If you're comfortable adding, subtracting, multiplying, dividing by fractions, then you don't have to do anything special. I have 3/2 times X. I have plus 7/4. I want to get rid of the 7/4 by subtracting it. So minus 7/4. So I do that to one side, I have to do it to the other. Now, if I'm subtracting fractions, they have to have the common denominators. So I'm not going to subtract 7/4. I'm actually going to subtract an equivalent amount, 14/8. If I multiply 7/4 by 2/2, then I get 14/8. So subtracting 7/4 and subtracting 14/8 is the same amount, but now I've got denominators of 8 on the right side, and they can cancel, and I can subtract these appropriately. So what's my new inequality? These cancel out, and I'm left with 3/2. So I've got 3/2 times X is less than or equal to 63/8 minus 14/8. We still have 8s. And then 63 minus 14 is 49. So I've got 3/2 X is less than or equal to 49/8. Now, you can see that number right here, but that clearly isn't the answer because 3/2 times X is less than or equal to 49/8. This just says 1X is less than or equal to 49/8. So that can't be the answer because 3/2 times X is less than or equal to 49. So this is going to be the answer. How do we figure that out? What exactly is it? Well, if you want to solve for X, you always divide by the coefficient. In this case, our coefficient is a fraction. So how do you divide by a fraction? You simply multiply by the reciprocal of that fraction. So to divide by 3/2, I multiply by 2/3. If I do that to one side, I must do it to the other. So I'm multiplying both sides of this inequality by 2/3. Over here, I end up with just X, which is what I want, is less than or equal to. And then over here, I can do a little bit of simplifying. 2 and 8 both divide by 2, so that becomes a 1 and a 4. And I have 49 times 1, which is 49, and 4 times 3, which is 12. And I have my answer, which is X is less than or equal to 49/12. So that's how you do that problem. But there are other ways to do problems. If you don't like dealing with fractions, if you don't like multiplying, dividing, adding, subtracting fractions, and you want to try and make it easier on yourself, you can do that. Let's write the exact same problem, but do it slightly differently. I'm going to start with 3/2 X again, plus 7/4, is less than or equal to 63/8. So one way to do a problem like this, if you have all fractions and you just don't like fractions, you want to get rid of them, is that you can multiply the entire inequality or equation. This also works for equations. You can multiply it by the lowest common denominator, or in other words, the lowest common multiple of all the denominators. So what is the lowest common multiple of 2, 4, and 8? And the answer is 8. All of these numbers multiply into 8. So if I multiply everything by 8, everything on both sides, I won't have fractions anymore. Watch this. If I have 8 times 3 halves, that's the same as 8 divided by 2, which is 4. 4 times 3, which is 12. So that would be 12 times x now. So 8 times 3 halves is 12. 8 times 7 fourths is the same as 8 divided by 2. Or, excuse me, 8 divided by 4, which is 2. And 2 times 7, which is 14. So plus 14 is less than or equal to 63 eighths times 8, which is just 63. So now I've got a brand new inequality with no fractions, and I can go ahead and solve that. And I solve that by subtracting 14 from both sides, and I get 12x is less than or equal to 49. And last but not least, I can divide both sides by 12. And if you divide both sides by 12, you get x is less than or equal to 49 twelfths. So there you go. Next one, Angela's parents have allowed her to watch TV for a maximum of 7 hours a week. She has already watched TV for 3¼ hours this week. She wants to watch some episodes of her favorite shows that are 3/4 hour long. How many episodes, X, can Angela watch this week? Sketch the graph of the inequality that represents the maximum amount of episodes she can watch. So again, we're talking about a maximum, which means our answer should be less than or equal to a number. Look at our graphs. Which of these graphs stand for less than or equal to? Well, the ones that are pointing left represent less than. So we're talking about A or D. And if you have the or equal to, they're solid dots, but all of our graphs in this option have solid dots. So it's going to be A or D. Those are the ones that say less than. These other ones, B and C, are greater than. So it's kind of like the last problem. These don't make sense in the context of this particular problem because they're greater than. She's saying in this one that 3½ is the minimum amount of TV she can watch. And that just doesn't make sense. We have a limit on how much she can watch, not a unlimited amount that she can just watch as much TV. So we know the answer is going to be A or D. So it's either going to be less than or equal to 5 or less than or equal to 2½. So let's go ahead and write an inequality for this one. First up, the maximum is 7 hours. So everything that we're going to put together here has to be less than or equal to 7 hours. It says her maximum amount of TV she can watch is 7 hours. She's already watched 3¼ hours, and each of her favorite TV shows is 3/4 hour long, and the number of shows she's going to watch is X. So the first thing we're going to do is we're going to say 3/4 hour times the number of shows is the total amount of time that she has left. So 3/4 hour times X, that's how much she still has left to watch, plus the 3¼ that she's watched already, has to be less than or equal to the 7 hours maximum. So that's our inequality. 3/4 hour times the number of shows, because each show is 3/4 hour, plus the 3¼ hours that she's already watched, has to be less than or equal to the 7 hours maximum. So just like the last problem, you could do this without having to mess with anything. If you're comfortable with adding, subtracting, multiplying, dividing fractions, and mixed numbers, we've got no problem. So I can just subtract 3¼ from both sides. And what that turns into is we have our 3/4 times X is less than or equal to, and then we can subtract this. Now 7 minus 3 is 4, and 4 minus 1/4, because we're subtracting 3 and subtracting 1/4. 4 minus 1/4 is 3 3/4. So that's our first step. Now, just like our last problem, we want to divide by 3/4. So how do we divide by a fraction? We multiply by the reciprocal. So again, what I'm doing right now is I'm dividing by 3/4, because you always divide by the coefficient when you get down to this step. So I'm dividing by 3/4, and the way I'm doing that is I'm multiplying by 4/3. It's how you divide by a fraction. So those all cancel out, and I've got X is less than or equal to. I have to obviously multiply the other side by 4/3 because I multiplied the left side by 4/3. So here we go. How do I multiply 3 3/4 by 4/3? Well, you could do this multiple ways. You can multiply 3 times 4/3 and then 3/4 times 4/3 and add them together. So let's try that out. And I'll write out what I'm doing in case the way I'm doing this, you think, oh, Fager, you have to put them as improper fractions, right? You always do that when you're multiplying fractions, mixed numbers. You can, but there's another way to do this. If I have 3 3/4 times 4/3, that's the same as 4/3 times 3 plus 3/4, right? 3 3/4 is the same as 3 and plus 3/4. Well, if it looks like this, I could use my distributive property. I could do 4/3 times 3, and then 4/3 times 3/4 and add them together. I could do 4/3 times 3. I'm writing this all out. I wouldn't do this normally. I would just you could jump to this in your head, and if you get used to it, it goes really fast. I'm just writing this out for anybody that doesn't understand what I'm doing. So here we go. 4/3 times 3. Well, 3 divided by 3 is 1, and 1 times 4 is 4. So 4/3 times 3 is just 4. Plus, and then 4/3 times 3/4, you should know a number of times its reciprocal is just 1. So it's 4 plus 1, which is just 5. So the answer down here is 5. So when I go back up here, I do that in my head. I said 3 divided by 3 is 1. 1 times 4 is 4. And then 3/4 times 4/3 is 1. 4 and 1 is 5. So x is less than or equal to 5. So that's how I would multiply that mixed number times that fraction. But many of you got taught to always make your mixed number into an improper fraction and just always multiply that way. If you want to do it that way, you can. Here's how that would look. If you have 3 3/4 times 4/3 and you wanted to use improper fractions instead of the distributive property, it would look like this. You've got 3 3/4 times 4/3. So you're multiplying these two things together. 3 3/4. 4 times 3 is 12. 12 plus 3 is 14. So you get 14/4. Or excuse me, 15. 4 times 3 is 12. 12 plus 3 is 15. So you get 15/4 times 4/3. And the 4's cancel. You get 1 and 1. And then 3 and 15 both divided by 3. So you get 1 and 5. So it just is 5 over 1 times 1 over 1. So you still get 5. All right, next up, tomorrow, Mrs. Wendell's class will be using toothpicks for a science project. Each student must use at least 7 toothpicks for the project. Mrs. Wendell knows that there's already a bag of 50 toothpicks in the class storage room. She plans to buy X additional toothpicks, so X, some mystery number of additional toothpicks, to make sure that her class will have enough. If her class has 24 students, which number sequence represents this situation? So again, we've got 7 toothpicks already. Or excuse me, every kid needs 7 toothpicks. We have 50 toothpicks already. And we need to buy X additional toothpicks. So it's going to be 7 toothpicks per kid. And there is 50 toothpicks that we have already. Her class has 24 students. So how's that going to work out? So just like before, we can kind of look through our choices here for some common sense. If X is the number of toothpicks she's going to buy, and she wants to make sure she has enough, then this time she has to buy a minimum of a certain number. She can buy more than she needs, but she just cannot buy fewer than she needs. So we're going to have something related to X, and X has to be greater than or equal to some other number. It has to be more than the other number or equal to it for it to be enough. It can't be less. So which one of these statements has our X on one side of the inequality and then a greater than or equal to symbol? And we've got B and C. We've both got X's right here and then greater than or equal to symbols. With A and D, it says less than or equal to, which means the number of toothpicks that you could buy could be, 0, and it would probably fit the inequality. And that doesn't make any sense. So we're going to go ahead and choose B or C here. Now, they both start off with 1/24 times X. Why would that be true? Because each one of her kids, there's 24 of them. So each one of the kids is 1/24 of the class. So each kid is going to get 1/24 of the toothpicks she buys, theoretically. Now, they differ in what they add to them. One is adding 1 and 1/24, one is adding 2 and 1/12. And they say that those added together have to be greater than or equal to 7. Basically what this is we have the 50 toothpicks divided by the 24 kids. If you have 50 toothpicks divided by 24 kids, how many toothpicks do we already have per kid? Well, 50 divided by 24 is literally just the fraction 50 over 24. 24 goes into 50 two times with 2 left over because 2 times 24 is 48. So it's a 2 and 2/50ths. And you can, excuse me, 2 and 2/50ths, 2 and 2/24ths. And then you simplify 2 and 2/24ths to make 2 and 1/12. So that's how many toothpicks we have per kid already. 50 toothpicks divided by our 24 kids is 2 and 1/12 toothpicks per kid. So each kid is going to get that much, and then you have the 1/24th of the ones she buys. Those combined have to be greater than or equal to 7 because each kid needs 7. Moving on, Kayla has a weekly budget of $830. She works at a clothing store and makes $225 per week, plus 20% commission on the merchandise she sells to customers. The graph below models the dollar amount of merchandise Kayla sells each week. Which of the following is a correct interpretation of the solution? So it says Kayla can sell $3,025 or less to reach her weekly budget. Well, right away, is this representing that she can sell something or less? No, it's pointing to the greater side. So she can sell that much or more. So Kayla can sell less than $3,000? No. Kayla needs to sell $3,025 or more. That's the right answer. D is not right because it says that she needs to sell more than that much. But the solid dot on the graph indicates that she can sell exactly $3,025 and meet the goal that she needs to meet. Number 5, Jackson volunteers at local charity at a local charity filling bags with food. There are 20 bags already filled. Jackson can fill 35 bags with food per hour. Create an inequality showing the number of hours, X, Jackson needs to volunteer in order to fill at least 1,000 bags with food, then solve for X. So there's already 20 bags filled, and Jackson can fill 35 bags per hour. He needs to fill at least 1,000, and every hour is X. So this has the X in it already. So what are we multiplying by X? We have to put in this box the number we multiply by X. X is the number of hours. Jackson fills 35 bags per hour. There's the per hour. So we're going to do 35 bags times the number of hours. So 35 times X. To that, we're going to add the number of bags that we already have, which is 20. Now Jackson needs to fill at least 1,000 bags. So he can fill exactly 1,000 bags or he can fill more, which means that these things added together, the 35 bags times the number of hours plus the 20 bags are already there, has to be greater than or equal to 1,000. So there's our inequality. 35 times X plus 20 is greater than or equal to 1,000. So 35 times X plus the 20 is greater than or equal to 1,000. So we can go ahead and solve that inequality by subtracting 20 from both sides. Subtract 20 from both sides of this, and you get 35 times the number X is greater than or equal to 980. And then finally, we divide both sides by 35. And we get X is greater than or equal to 980 divided by 35. So 980 divided by 35 is one of these. Now you can go ahead and use a calculator if you need to on this. Not everything that you guys do I expect you to do by hand. It's okay to have some time-saving tips. You can also go through each of these and kind of use a little bit of common sense. The 1,000 you already used, the 35 you already used, unless you think 980 divided by 35 is 35, which it's not. So yeah, use some common sense or use a calculator. It's up to you. Your tools should have a calculator available to you on this assignment, but if it's not, you can just type it in the URL bar, pull up a calculator on your computer. You can also simplify the fraction if you want to. Both of these divide by 5. You can simplify and make this an easier division problem. 35 divides by 5 7 times. 980 divides by 5. Well, every 100 is 20. I mean, it goes into 1,000, the number of times that you would expect there for that. So there's lots of different ways to do this problem, but either way, you should end up with 28. And don't forget to bring your inequality symbol down. To date, this year, company XYZ has sold 525 units. They sell units at an average rate of 15 per week. The company wants to sell more than 750 units this year. Which of the following inequalities could be used to solve for X, the number of weeks necessary to reach the company's year-end goal? So they have to sell, according to this, more than 750 units. Okay, more than. So our answer should have a greater than symbol. And these all do in this one. It doesn't help us to eliminate anything here because they all have the correct symbol. Now they sell 15 per week and they've got X weeks left. X is the number of weeks necessary. So we're going to say 15 times X to get the number that they're going to sell over that period. They've already sold 525. So we're going to add the 525 to the 15 times X. And that is A. That has to be greater than the 750 that they're trying to sell. Katie and Rebecca are each trying to earn money to pay for their sports activities for next year. To help Katie earn money, her parents told her she could walk the dog every day of the week. Katie has $525 already saved. She earns $25 per week walking the dog. Her goal is to have $1,250 to play on the soccer team. To help Rebecca earn money, her parents told her that she could do the dishes each night of the week. Rebecca already has $510 already saved. She earns $30 per week washing the dishes. Her goal is to have $1,350 to play on the hockey team. Determine whether Katie or Rebecca will need more weeks to reach their goal to participate in their sports activities. Use an inequality graph to graph the possible number of weeks that person will need in order to reach their goal. So we're just solving each of these inequalities presented to us in this problem, and whoever needs a greater number of weeks, because it says determine whether Katie or Rebecca will need more weeks, whoever needs a greater number of weeks is the person that we're going to graph. So let's go ahead and solve one of them at a time. We'll start with Katie. Katie earns $25 per week, so we can say 25 times X. She's already got 525, so we'll add that to her amount of money. So she's going to earn $25 times the number of weeks. So that's how many weeks that she has left, plus the $525 she already has to be greater than or equal to the amount of money she needs, which is $1,250. So the amount of money that she's already got, 525, added to the amount of money that she's going to earn in the coming weeks, which is $25 times the number of weeks, has to be greater than or equal to the amount that she needs. So we can solve this. We're going to subtract 525 from both sides. And we get 25 times X. It's greater than or equal to, and that looks like 725. Then we divide both sides by 25. And we're dividing. X is greater than or equal to. So 725 divided by 25. 25 goes into 104 times. So it goes into 728 times. It's one more, so it's 29. So X is greater than or equal to 29. So that's Katie. X is greater than or equal to 29. Let's go ahead and solve for Rebecca now. Rebecca, she's got X weeks, but she earns $30 per week. So she's $30 times the number of weeks. Plus she has $510 already saved. And that has to be greater than or equal to the amount she needs, which is $1,350. So now let's go ahead and solve her inequality. Subtracting 510 from both sides gets us to be 30 times X is greater than or equal to, looks like 840. So then we're going to go ahead and divide both sides by 30. So we get X is greater than or equal to 840 divided by 30 is the same as 84 divided by 3. 60 divided by 3 is 20, and 24 divided by 3 is 8. So that would be 28. So 840 divided by 30. So who's more? We obviously, one of them was 29 and one of them was 28. So our 29, and that belongs to Katie, is going to be the higher number of weeks. So now we're going to graph that. So we're going to have a ray, because that's a solid point on one side. We're going to go on to 29. It has to be that much or more. So there we go. That's our answer. All right, number 8, Sophie earns $12.80 per hour babysitting. She has to repay a loan to her parents in the amount of $100. After repaying the loan, she wants to have at least enough money to buy herself a pair of sneakers, costing $130.40. Very expensive sneakers. Write an inequality modeling the number of hours, X, Sophie needs to work to have enough money to buy the sneakers. So she's got $12.80 per hour babysitting. She's got to pay off $100, and then she needs $130.40 left over. So we got to figure out how much money she needs at $12.80 per hour to have enough money for this, plus to pay back the loan. So that's what we're looking for. $12.80 times the number of hours minus the $100 she has to pay back to her parents needs to be greater than or equal to the $130.40. So we'll go ahead and write that inequality. Again, she's going to pay $12.80 per hour times the number of hours. Then we're going to subtract from that amount that she earns. This is all the money that she's going to earn babysitting. Let's take away the $100 that she has to pay for her loan, because we're going to take away that from the total. What she has left needs to be greater than or equal to the sneaker amount, which is $130.40. So there's the inequality. She has to earn enough to pay back the $100 and then still have $130.40 left over. So obviously that means that, and this is what a lot of you may have jumped to right away, and it's okay, if you have $12.80 per hour, that needs to be greater than or equal to $230.40, which is the amount for the sneakers plus the amount for the loan. If you were doing your basic arithmetic, that's probably what you would have jumped to right away, and that's okay. $12.80, don't forget the times X like I just did. $12.80 times X is greater than or equal to the $230.40. And you go ahead and divide by $12.80 on both sides. And I'm not even going to attempt to do that one. I'll just go ahead and pull a calculator out at this point. So here we go, $230.40 divided by $12.80 equals 18. So she needs to work at least 18 hours. So 18 is two of these choices. But if she works less than 18 hours, that's not going to be enough. She has to work greater than or equal to 18 hours. Okay, moving right along. Philip is having a party and wants to spend less than $632. He's already spent $500. The only item left on his list is sodas, which cost $12 per case. How many cases of soda, X, can Philip purchase to stay under his budget? So we're going to go ahead and count the entire number of cases, X. We're going to multiply each of those by the cost per case, which is 12. And then at that point, we just subtract from the other dollar amount. So here we go. $12 per case, 12 times X, plus the $500 he's already spent, has to be less than or equal to the total amount he wants to spend, which is $632. Because we can spend $632, or we can spend less, but we can't spend more than that. That'll be over his budget. So I can now subtract 500 from both sides. So 12 times X is less than or equal to 132. We divide both sides by 12. And I get X is less than or equal to 11. 12 goes into 120 10 times. 132 is 12 more than that, so it's 11. So he can buy 11 cases of soda. Now, can he buy exactly that amount? Yeah. Can he buy more than that amount? No. Can he buy less than that amount? Yes. So really, we could have done this entire problem just looking at our answers, because we have, actually, I'm sorry, he wants to spend less than $632. So you may have noticed I did something wrong. This entire time should not have been a less than or equal to symbol. It says less than $632, not less than or equal to. It doesn't say at most $632. So this should have been a less than symbol, not less than or equal to. Similarly, all of these then coming down would have been less than symbols instead of less than or equal to. I didn't read that problem carefully enough. So be careful, you're liable to make a mistake like I almost just did here. It says less than $632. So $632 is too much. So looking at all of our options, they're all appropriately designed. You have less than for all of these. Notice that none of the dots are filled in. So we're going to pick the one that says less than 11, which is A. Okay, number 10, a cat adoption facility takes in an average of 5 cats per day. The facility has to keep their cat occupancy below 300. So right away, like the last problem, this is going to be less than 300. 300 doesn't count. It says below 300. Currently, the facility has 255 cats. If none of their cats get adopted, how many more days, X, can the facility continue to take in cats? Select the inequality that includes the largest number of days the facility can continue to take in cats without exceeding its occupancy limit. So it has to be below 300. So we've got 5 cats per day, so 5 times X, plus the 255 cats it already has to be less than 300 cats because it says below 300. So we'll go ahead and subtract 255 from both sides. So I got 5x is less than 300 minus 255 is 45. And we'll divide both sides by 5. And x is less than 9. So there we go. That's it. X is less than 9, D. So that's it. Good luck. If you need any help, sure you reach out for it.